Welcome everyone to another observability clinic, elevating security with Davis Anomaly Detection, how Davis AI detects anomalies in authentication error patterns. I have David and Gerhard with me. Hi guys, how are you doing?
Hi, Andy. We're good. Great
Hi,
weather.
Andy. Thanks for having us.
Yeah, thank you so much for doing this and actually bringing use cases to our community. Before we, I think, go into the use case, David, I will want to kind of give it over to you because you want to do a little recap on a Davis AI anomaly detection, and then we hear from Gerhard around how we can really apply this in a security use case. So, David, please take it away.
Thanks, Andy. Thanks for having me again. Another session where we see some more use case about Davis anomaly detection in other solutions. Today we have security. Thanks, Gerhard. Also, you presented afterwards. As you already mentioned, today I give you just a short recap about the Davis analyzer. I always mentioned the last couple of videos about how you select the Davis AI analyzer, and you can see some baseline and so on. But today, I would like to share more in detail what's back in the behind the scene, how does the analyzer works. And for that, I created notebooks on our playground. You see on the QR code, or you see down the link, the share link to that, where you can also try it out and play around a little bit, and also learn about the difference from the analyzers. So let's jump directly in and play around with it. So I hope you can see my screen now.
Yeah,
also
good.
That's good. Thanks, Andy. So as I said or mentioned, for anomaly detection, we have three analyzers in place. We have the simple and very effective the static threshold. Then we have the auto depth threshold, and then later on the seasonal baseline. So we're starting with the simple and effective one, the static threshold. So it represents the hard limit where a time series should not violate. Yeah, you set a boundary on that, and you want to get a violate on it. And for that, you're always using, I guess, mostly the static threshold on known metrics that you're aware of it. Like I want to get alert of high CPU usage. Then you set, of course, a threshold on around 90, 95% on that. So let's start how you select it. Yeah. So you go here, you see a time series, you go in options, then we go to Davis AI, activate it. And then you see here, as we are also going through the three anomaly detection lines. So we select the static threshold. And what you also have here is like a button, if you don't know, like here, for example, yeah, with a DNS query time metric, where we say, okay, what kind of threshold I should set. And you can also ask Davis to suggest a value, and then he gives it to you a threshold, which is given in like to take the last 7 days and look, okay, what was normal in the last 7 days. So you can click it and see, oh, that's very fine. So thank you, Davis, that you're helping out to create a threshold. But most of the time, you also know it already, as I said, like CPU usage or memory usage, you want to always set the boundaries. Again, just to remember it, also we have the show advanced properties that you see here. We have the 3 or 5 sliding window that says, okay, between 5 data points, when 3 of them have a violation, then raise an alert. So we change it to 1 again and run it again. And we see also the spikes here, the simulated potential alert on that. Yeah. So
that's a really cool, just a recap here. It's a really cool capability to actually play around with these anomaly detection settings so you can see how many alerts you would actually create. It's a really great way to just learn a little bit actually how the anomaly detection really works and how it would then impact potential problems that are coming up. Really nice.
Yeah. So we're only using notebooks as a playground to set up an anomaly detector. And then first we want to simulate, play around. Okay, this is a perfect fit for us. This is a perfect settings, and then you create an anomaly detector afterwards. So the next one is the auto depth threshold. before going in detail how that works, so in short, the auto-adaptive threshold take the last 7 days of each dimension of the metric, so individual, and create a baseline on that. But before going in detail how this works here, I would just also say the difference between the static threshold and auto-adaptive threshold, where it's also automated, so there's an automation behind it, but there has some disadvantage also. So what I'm having here is like, I have a memory time series metric. And what I'm simulated is that when you have a time series that's slowly increase over time. So I have a week 1, and just multiply with 1.25 and a week 2 afterwards. And then if you have an auto-adaptive threshold on that, it also, you have a higher, for each week, a new threshold. And you never get an alert on that. So this is something you should also be aware. So when you activate and have already auto-adaptive threshold, then we see here that we have for each one an own, also when you split it up in weeks, so for week 1, we have a threshold of 43.8, and the week after 52. So it's parallel increase it. So you should also be aware when I should using auto-adaptive threshold, when using static threshold. So it's more also to bring it out the versus. So both have advantage and disadvantage, I would say. But not everything automated is better, I would say. Of course, we like to do it that everything is automated.
Would that be a best practice then, that you combine both? That you combine an auto-adaptive baseline with a static threshold, because if you have a certain upper limit you never want to cross?
That's a good point. And yes, it's you set up 2 configs, I would say. The one with the adaptive one, that's increase it, and then you also get, where you have a spike here, immediately you get an alert on that. If you want
that means if I recap, if I have memory, let's say memory usage, I want to make sure to get definitely alerted at 80% full. But then if it's at 20 all the time and it jumps from 20 to 30, that's a significant increase. So I want to get alerted based on the other auto-adaptive threshold. So I think that sounds good.
Yeah. So of course you want to kind of create 2 configs, and you gain the both benefits of it. So let's go in detail how this behind the scene anomaly detection, the auto-adaptive threshold works. To do so, I have also something very prepared. We see here, I've chosen already the analyzer for that. And we also see here the number of signal fluctuation. So what does it mean? What it does is helping you to increase the confidence band of the sensitivity. Now I put it 0, to simulate when you don't have a signal fluctuation. We calculating, so without considering signal fluctuation, is a quantile of 99% of your last 7 days of each dimension. So we're not using 0, of course. We want something is automated, and you don't want to get an over alert in that for sure. So when you consider that, okay, signal fluctuation, I put like 3, for example. So considering signal fluctuation is the 99 quantile, without it, plus the tolerance. So that's the number 3, multiple the signal fluctuation, and it's a quantile 75 minus quantile 25 from the last week on each dimension of your metric. So when you run it, then you see the confidence bands increase that. To not get over alert, as again, I have already to showcase the violation of 1. You can change it to 3, and then it's everything fine. And on this spec, of course, I want to get an alert. This something is very higher than was before. So, and what's very powerful is here, say on each dimension. So when I have like here again, the DNS query time on each individual time series, splitted by source entity, and own threshold we automatically every day calculated and set up a threshold for that. So there are many use cases where you say, okay, my systems or my environment is so different. Yeah, I don't want to create a tag in a group or something like that. You can take everyone and create a threshold automatically in time. The next part is more, of course, a more complex one. Yeah, and the seasonal baseline. Yeah, for that, I have a short overview how the process looked like. Yeah. It's also written in documentation. Yeah, if you go to seasonal baseline, you see, learn more, and then you will jump directly to documentation, which also explain it. But I give you a short intro on that. So we have the data validation up front is checking the requirement. Okay, do you have enough data points to that we can see if a seasonal pattern or not? If not, then you jump into the simple model. What does it mean? I will explain later. Let's go through it. You have enough data. And the next part is the data pre-processing that says, okay, we checking a robust seasonal pattern of your time series. Doesn't matter it's minutes or in days or in 50 minutes. We indicate a seasonal pattern on that. We take a time day feature that says, okay, on Mondays and Tuesdays and so on. And of course, the autoaggressive feature. So there are many features behind it in this model to check and set up the quantum regression model to set up a confidence band on each line. And after that, we're checking, okay, which of one are really a seasonal one. Then the model validation checks, okay, you can go through it and see what is out of the bound. Then you have a detection. If not, it doesn't mean it's not. You don't get any anomaly detection on that. It is, if it's not fulfill the requirements, it's coming back to the simple model, and it's kind of a meter like the adaptive threshold. So at least on each line, you will get a threshold. Either it's consistent, but it's not seasonal, of course, then it's consistent. And if it, then we have a beautiful band on that. Also here to showcase it here, for example, also between the consistent auto adaptive threshold and seasonal baseline, I have here, for example, choosing one auto adaptive threshold where we see all the spikes. So say I will get more alert when I change it to 1 again, for example. But we see here some great seasonality here over the last 7 days. So I can choose seasonal baseline and then we create. Oh, no, wait a minute. Seasonal. Yeah, now I have it. And we see here beautiful seasonality here in the band. Yeah. So, yeah, so that's currently we have now on, I would say, on our DVCI analyzers. As I also promised, there will more to come. Yeah. Like forecast, so anomaly detection on forecast and so on. So yeah, then in the future, when I will have another session, then you will find you will find another analyzer here then.
Sounds good. Hey, and also thanks, David, for preparing this notebook, folks. The notebook is linked in the description. The best is on the playground. Everyone has access to the playground, so follow that link. Ideally, I would say create a copy of that notebook because David has shared it read-only. So when you create a copy, then you can also play around with it or just download it, install it, or import it in your own Dynatrace tenant, and then you can play around with it on your own data, which I think is really cool. Yeah. Thanks, David. Anything else from your side, or shall we see some adoption of all of this from Gerhard?
Yes, I want to give the mic over to Gerhard.
Perfect. I think you probably want to stop sharing and then Gerhard can take over.
Thanks a lot. Thanks for this great introduction. So after this really deep jump into how the anomaly detection works, I would take it back a step and think about how can we utilize the great power that we get with the Davis anomaly detection. So my use case today that I want to present to you is detecting anomalous authentication error patterns. But before we go into the details, I would like to talk about why is anomaly detection key for security. Basically, cyber attacks are becoming more subtle, more powerful. Adversaries are getting better in masking them. They launch something else to sidetrack you from the real thing. And combining that with more complex architectures, exponentially rising amount of data, and it gets more and more difficult to detect this needle in the haystack that we always look for in the security. So Dynatrace already provides security protection and security capability, security analytics capabilities to deal with a lot of security use cases. But now with Dynatrace's Davis anomaly detection, we give you another pillar to improve your security with. So let me highlight a few points here. Using anomaly detection allows you to identify unusual patterns that may indicate security breaches early. And this helps you to minimize damage by addressing potential threats immediately. You have all this data incoming from the observability side, like metrics, like logs, like spans, like traces. And the amount of data generated is rising rapidly. So going through it manually is getting more and more difficult. Questions arise like, do I get all necessary data, or did some forwarding process or log ingest process fail? Keeping an eye on all of this is not an easy task. You need an intelligent, automated advisor like Davis to alert you to where you need to focus your investigation. There are a lot of insights to be had from identifying unusual behaviors from humans or other systems. But data flow or behavior is usually not static or linear. So relying on your rule-based system is often not productive. Thresholds and rules are very ineffective on periodic data or processes. Creating a baseline with periodicity or seasonality and evaluating outliers above and below this baseline is much more efficient and effective in identifying anomalous behavior. Which brings me to the next point. Putting data on glass and providing dashboards to see any potential problems is very important. But it's only the first step. Having a person needing to watch dozens of dashboards manually for any outliers in time is time-consuming and, of course, error-prone. Mm-hmm. So this early detection allows for quick response, minimizing potential damage, as I said, but only if you get notified and alerted, automated, and quickly. So how does anomaly detection fit into an incident evaluation chain? It all starts with the data incoming from different sources, either automatically via one agent or forwarded to Dynatrace via open pipeline. Data is key. Both observability and security data needs to be leveraged to get the full picture of what's going on. Anomaly detection then sits on top of the data in our Grail data lakehouse. And it lets it evaluate all the data that's inside. As I said earlier, one of the use cases here is to check if incoming data flow is working. To be prepared for an incident investigation, you need to make sure that all necessary logs are available. And on top of that, being notified quickly about a detection is, of course, key to start an investigation into possible threats as soon as possible. And talking about possible threats, I would like to visualize two types of anomalous behavior that we can detect here: intentional and unintentional anomalies. Intentional anomalies are where someone is doing things that are out of the usual patterns, but on purpose. For example, an administrator changing settings in your cloud environment. This is not a regular task and thus will be picked up by the anomaly detection. Unintentional anomalies, on the other hand, are where there's no planned action behind it. Both will be picked up by Davis and both needs to be investigated. But the unintentional ones are where we need to identify if it's a potential attack or a benign behavior. So enough of the theory. Let's take a look at how it's done really. So the use case I want to show you today is about identifying anomalies in the authentication error counts. Why do I want to do this? Because error counts are usually a good measurement if anyone is probing a system. This is usually one of the first steps of an attack called reconnaissance, where systems are being probed for potential vulnerabilities. Another use of this is when an adversary is trying to brute force an account. So let me switch over to my environment so we can take a look at how it looks in real. So as David told us, I'm starting with a notebook to take a look at the logs that are there. And in this case, I'm assuming the role of a security administrator. I'm looking at a notebook where I can check out my queries. I have my application running on an EKS cluster, as you can see here above. I'm interested in the API server logs that are part of my Kubernetes cluster. And of course, I'm interested in the error response codes 401 and 403, which both indicate an authentication error. And if I run this query, as you see below here, there is already a lot of that. And being able to identify a pattern in here would be very beneficial. So adding a time series here, you see that there is a certain periodicity to this error counts. And with this, I can take the query that I got here and open it with my trusted Davis Anomaly Detection. This opens me the dialog to add a new anomaly detector, and I need to fill out a few fields here. So let's start with a title. I call it Authentication Error Anomaly. A description is not mandatory, so I leave it out for now. And here I would say the source is the Davis Anomaly Detection. Moving on to the query, it's already what I had in my notebook. So this is already pre-filled here, meaning that I don't have to do anything here. Then there is the customization parameters that David mentioned as well. I like the seasonal baseline because for me, log ingest can vary, as same as error counts can vary over time. So maybe there is a time in Monday morning where people are starting to log on and are generating more and more error logs because they simply mistype their passwords. And this is on statistical level taken care of by the seasonal baseline. And the tolerance depends then how to tweak it. So this is something that I will later play around with to see if I'm not getting overloaded. And then the last part here is to give the whole event a name. In this case, I will call it Authentication Error Count Alert. And then an error description, maybe something we like authentication count exceeds normal pattern. Mm-hmm. And then down here, you see already a few event properties automatically filled in. So the name and the description that I just added, then this is a custom alert and the source entity that this is based on. And with this, Davis tells me that I have a big query. So to help it trim it down, I will focus on a smaller interval. Mm-hmm. And with that, I can create my error anomaly. So as you see, there is one here that I just created. And as you probably see here, there was an older one there because I wanted to show you what happens if this event is triggered. So as I said, the anomaly detector creates an event, and the event can then be picked up. So in this case, I created a workflow that picks up this event. So this is the same event that I just created, then checks the ownership information here, and then basically sends me a Slack message, or sends the owner a Slack message, basically, because I want to notify the person who's responsible for the cluster. Or I can create a Jira ticket out of it. So all of this is completely depending on the workflows that you use, and can be from super simple as here to much, much more complex with a lot of checks and balances in between. But in this case, you see, I created here an Slack message into a certain channel. And if I take a look at my Slack, I see that already earlier today, I was already alerted that there was an authentication error count outside of the normal pattern, the things that I added to the event. And now I switch from the person setting up the system and creating this anomaly detectors to the person identifying what is happening now. Because I, as an administrator, set it up so that the right person got this alert. And now, as the security investigator that needs to know what happened, I take the query provided here by the system already, and move back to Dynatrace and open up my security investigator to follow up on the investigation or start an investigation and follow up on the alert. To do this, I open a case and use the query I copied over from the Slack message to start me off. So as you can see here, and I hope it's still visible, there are a lot of events that fit into that created the anomaly basically. And one of the key indicators here that I can see are the source IPs. So what I would like to do is summarize by source IPs with account. And as you see, there is a few source IPs here that requested requested data from our API server and created an authentication error. Looking at the biggest one, it's this one. So I would like to take a look at that first. So what I do now is to not summarize, but filter by IP. Sorry, in IP, of course, in the field source IPs. And since this is a array, I need to add this one. So that's, if I typed correctly, this. And as usual, if you do it live, there is an error. So let's do it like this. And now I already see there is still a lot of messages. And maybe I'm not interested in only the wrong ones, but I'm interested in all of them. So now I can remove the filter. And since this is a complex data field, I can extract the fields here. And since I know this is a Kubernetes audit log, we have already in our DPL architect a pattern that I can reuse here. So if I add the pattern here, I just need to rearrange it a bit because the pattern that I used earlier is not interesting, but the filtering I like to keep. And for visibility, I put it down here. And then adding to that, I would like to focus on a few fields like the request, the user agent, and the response. And running this query shows me what requests were issued against my API server, and it's basically who did it. I know the IP address, but with the user agent, I have a good indication of what kind of request this is. And as you see here, there's a lot of 200s and a few errors. So I would assume this is some kind of automated script going rogue at some point. But I can immediately jump back to the list of IP addresses back here. And since this one didn't pan out as relevant, I can just take a look into another one. So for example, this one. Copy over the IP address, go back to my query, and as you see, conveniently, everything is stored. So I just need to switch here to a different IP address and see what is happening there. And that is obviously somebody tries to reach my slash here with a C URL, which is usually an automated tool for probing. So this could be already an indication that somebody is trying to probe my environment. And with this, I can continue going deeper, branching off at a different point and investigating what is necessary there, all based on the anomaly that was detected initially.
Really cool. Hey, I need to quickly recap because I always in the end like to recap. You are obviously an expert when it comes to understanding what patterns we want to look into, like the number of HTTP 400s that indicates that somebody is either trying to log in with different user IDs and then is failing. So you basically started off with saying, we know we have this system, we know we have failed attempts, but we want to get alerted in case there's an abnormal behavior. Maybe somebody tries at an unusual time to actually hit the API and then it's resulting in a 400. So that was the first thing, you get alerted in case there's an abnormal behavior. And then you took this information and then took it into the triage where you're using the security investigator here, which, by the way, folks, if you're watching this, we have a video on the Security Investigator app as well. If you want to learn more on how to use this app, we have it available. But then you dig deeper or it's really cool because you basically have a really nice end-to-end use case. So have Davis tell if something is abnormal, and if it is abnormal, go into the triage, but don't get bogged down on analyzing things that are just normal behavior.
Exactly. You put it right on the spot. This is where we want to focus on the things that are relevant, especially on the analyst side. I really need to focus my time and my energy on the things that are really relevant, and to let Davis take care of all the other things that I don't need to investigate.
Perfect. Cool. And then I assume, I know you showed the workflow earlier where you were sending a Slack message or you can create a Jira ticket. Workflows are very flexible. You could also, I guess, create a link in that message back to the problem that was detected. You could put in a link that directly opens up a security investigator. So folks, workflows are even more powerful. So you can do a lot of things, but just the basic stuff that you showed is already so helpful because you only get alerted on an anomaly. You get all the context, and then we give you the additional tools to dive in and investigate. Really nice.
Exactly, and that is the power that the Dynatrace platform gives you. You are flexible enough to mirror all your processes, depending if you I don't know, open a ticket to a special project, or alert somebody on Slack, or create a ServiceNow alert, or whatever. All of that is possible with the power of the workflow engine in Dynatrace.
Perfect.
So I would like to come back for a second to my slides and show you one more thing. So that was basically a very simple use case that utilizes the Davis anomaly detection. But anomaly detection unlocks a lot more use cases for security. Starting, for example, with data availability and freshness, having prepared log failure alerts in advance helps you to avoid situations where you don't have the logs prepared when you need them, or detecting unusual activities in your cloud or in important accounts are especially important and are now possible with the DQL and the Davis anomaly detection. So to wrap it up from my side, when implementing your threat observability with Davis AI anomaly detection, there is no silver bullet that covers everything. You simply need to identify where are your important jewels that you need to monitor and protect, and think about how to do that. And additionally, what data do you need for an investigation? And how can you make sure that you have it in time so you don't sit around and have to grab your cloud data or something like that. Mm-hmm. So I hope I could show you the power of anomaly detection in the security context. And with this, I invite you to try it out and elevate your security. And with that, I give it back to you, Andy.
Yeah, thank you so much. You definitely showed us, both of you, what the core capabilities of Davis AI anomaly detection can do. And especially this list here is a great starting point for everyone to understand how they can then apply it to the field of security. So thank you so much. Folks, remember, David has shown a notebook that is available on the Dynatrace Playground. Everyone has access to it. The link is in the description. Also, we will put additional links in the description to the security investigator, to AppSec, to all the other things that Dynatrace can do in the security space. So check out the links. And if you have any questions, just leave a comment. That's also easy. You will find this both on YouTube as well as on Dynatrace University. And I know both of you folks, you will be back because I know there's a lot of new stuff coming all the time. Like David, you said, new anomaly detection algorithms that we bring in, and I'm sure, Gerhard, you will probably come back as well and just show us some of these other use cases, because I would love to see them live as well.
Glad if you want to have us back. I think both of us will be glad to be here.
Yeah. All right. With this, bye. See you next time. Cheers.
Bye.
Bye.